Chapter 3, Section 1, Rational Functions. So in this section we'll be identifying what a rational function is, finding its domain, finding any x and y intercepts, identifying vertical and horizontal asymptotes, and then graphing functions. Well, we'll graph some of them, let's put it that way. Other harder ones we will graph in Section 2. Alright, here we go. A rational function is a function that is a ratio. Maybe I should just type instead of dealing with my handwriting. The ratio of two polynomial functions. Alright, so we would write that in the form of polynomial functions. So if P and Q are polynomials, then R of x equals P of x over Q of x is a rational function. And of course, Q of x cannot equal 0. Alright, example 1. Determine if the following functions are rational functions. Explain your reasoning. So, the first one, we have 2x minus 1. That's a degree 1 polynomial. And then in the denominator, we have x plus 1. That's a degree 1 polynomial. So we have a polynomial divided by a polynomial, which means, yes, this is a rational function. Number 2, we have, in the numerator, we don't have a polynomial, because this would be x to the 1/2 power, and that is not part of a polynomial. But in the denominator, we do have a polynomial. That doesn't help us if the numerator is not a polynomial. So the answer is no. So denominator is degree 2 polynomial. Numerator is not a polynomial. This is not a rational function. All right, find the domain. So in our definition up here, I mentioned that the polynomial on the bottom cannot equal 0. That affects the domain of our rational function. So let's go ahead and find the values that would make the denominators equal to 0. So for number 1, x squared minus 9 equals 0 if x squared equals 9. And that happens when the square root of x squared is equal to plus or minus the square root of 9, which is plus or minus 3. I don't need to write the plus. Positive 3 or negative 3. So our domain can be written in set notation as x cannot equal negative 3 or 3, or in interval notation we could write it as negative infinity to negative 3, negative 3 to 3, and 3 to infinity. Let's look at number 2. So number 2, just giving myself a little more space to write here. X squared plus 9 equals 0. There is nothing that makes that true, because if we move this over here, we're taking the square root of a negative, and that's not possible. So there is nothing that makes this denominator 0, because we're always adding 9 to it. No matter what it is, we square it, it becomes positive, we add 9 to it. It's also always going to be bigger than 0. So therefore, our domain is all real numbers. There's no restriction from the denominator. Okay, now the next one's very interesting. Instead of solving it the way I just did this one, I'm going to notice something here, and that is that we could have done this by factoring instead. So this one technically would factor like this, and then you might say, oh, we can cancel these out. Well, yeah, we can, but if all we're doing is finding domain, we're not going to do that. So that means this one has the same answer that number 1 has. X cannot equal -3 or 3, and the domain is what I said over here, -infinity to -3, -3 to 3, and 3 to infinity.